Hello, pre-calculus students, and welcome to the lesson, or the continued lesson on functions. And this time we're talking about even and odd functions. And let's start with the definition. A function is even if f of x is equal to f of negative x, and it is symmetric over the y-axis. So I think it's best to illustrate this with an example. Let's see, I have an example. F of x is equal to 2x to the fourth. Let's see what f of negative x is equal to. So let's check f of negative x. And if you recall from earlier, this is just saying take this equation and just substitute negative x in there. Oops, and I forgot the fourth power. Okay. So if I take this equation and I work it out, well, negative x to the fourth is just negative x times negative x times negative x times negative x. So now I end up with 2 positive x to the fourth because I'm multiplying these negatives 4 times. And so you see this right here and this right here are the exact same thing. So I can take the original function, or I can substitute in a negative value, a negative variable here for x, and I get the exact same thing. So that makes it an even function. And if you were to graph this, it would look like this. Sort of like a parabola. It's probably a little flatter at the bottom. And in this case, you can see that there's a mirror image between the left side and the right side. That's saying that it's symmetric over the y-axis. And all you have to show in order to prove that it is an even function is to compute f of x, compute f of negative x, and that would be it. Now the graph is helpful, but it is not a proof. When we ask you to prove something or to demonstrate something, it must be done algebraically. The graph, very, very helpful, but by itself is not enough. So now we have a definition of an odd function. So if negative f of x is equal to f of negative x, if negative f of x is equal to f of negative x, then we can say that the function, the original function f of x is odd, and it is symmetric when rotated 180 degrees about the origin. So let's see an example of that. So if I have an example, f of x is equal to 2x to the third minus 3x. Is this an odd function? Well, let's see. Let's try our example here. Negative f of x, and if you recall from earlier, that's like just taking the entire thing, 2x to the third minus 3x, and then just multiplying all of it by negative 1. And so this is going to give you negative 2x to the third plus 3x. Okay, so that's negative f of x. What is f of negative x? And so that's like taking the exact same equation, 2, and then just writing in parentheses for all the x's, and then substituting in negative x. And you can see here that negative x to the third is negative x times negative x times negative x, which is negative x to the third again, because these you have 3 negatives here, so that's going to give you a negative. 3 x's, that's going to give you x to the third. So you're going to have negative 2x to the third minus, well, actually, it's going to be negative 3 times negative x, so it's going to be a positive 3x. You can see here that this part is the exact same thing as this part. Negative f of x, f of negative x are the exact same thing. So this function is odd. And we can certainly verify all of this on a graphing calculator. So let me type in the function, the original function, 2x to the third minus 3x, and we'll just graph in the standard window. And you can see that graph right there. Let me zoom in just a little bit. And I give you the graph so that we can see what happens if you take it and you just spin it 180 degrees. It's the exact same graph again. So that's what we mean when we say it's symmetric when rotated 180 degrees about the origin. So this is an odd function. The one we saw earlier was an even function. Now a function could be even, odd, or neither. So, because we have a little bit of time here, let's look at another one. Yeah, how about f of x is equal to 2x squared minus x plus 1. Well, this function, you can see it graphically. 2x squared minus x plus 1, and hit graph. It looks kind of symmetric about the y-axis, but it's really not. Okay, and that's where graph is sometimes helpful, but they're not always exact. So if we set f of negative x, this would be 2 times negative x squared minus x times negative x plus 1. So this would give us 2x squared plus x plus 1. And this part right here is different from the original. So it is not even. Okay. And I'll leave it up to you as an exercise to show that it is also not odd. So thank you very much for watching and paying attention and taking notes, and have a wonderful evening.